All right, well, and hey, everybody. Well, happy Friday. And so that means it's time for your weekly Space Hangout. My name is Fraser Kane. I'm the publisher of Universe Today. And with me, we've got Morgan Randberg.
Hey, Fraser.
Morgan. And we've got Nancy Atkinson.
Hi.
From Universe Today, a little rag we like to call Universe Today. And Nancy's just working on a really big story, and so we thought we would just get her to zip in for a second and give everyone an update. So this week, we're going to talk about, let's see, we're going to talk about NASA research spin-offs. We're going to give an update on Cosmos. Beta Pictoris rotation rate. Morgan put this in. I'm not sure exactly what we're talking about. Astronauts getting to space via trampolines, of course. 1 million updates on SpaceX. A cool picture of Uranus from Cassini. And this strange object that's about to be consumed by the Milky Way supermassive black hole. What is it? A selfie from Curiosity and a new live stream from the International Space Station. So now, Nancy, I know you don't have a lot of time. So why don't we sort of zip right over to you? Before we do that, I just let people know you can communicate with us. You can interact. We've got the QA app enabled for this Hangout, so go ahead, and if you want to make a post, you can do that. And another thing as well, just a reminder that if you don't want to watch the show live, I understand. And if you don't want to watch it on YouTube, I also understand. If you like your weekly chat show space news in audio format, you can download it from iTunes. You can get there's an RSS feed for all the audio versions. So just do a search for the Weekly Space Hangout on iTunes, and you should be able to get it there. And we're going to sort of make it more obvious all the places you can. But the point is, you can get the audio or the video download it directly to whatever device you want, and then you don't have to wait and be slaves to this online thing. All right, cool. So let's get rolling. So Nancy, big news: cloud moving towards the supermassive black hole, or is it?
Yeah. Well, yeah, it is actually, and since about 2011, astronomers have known about this gas cloud that's been heading towards the center of our galaxy, and this is really interesting because we've got this supermassive black hole there, and we don't get to see a lot very close up like this. I mean, relatively close up, of course. What happens when material or objects or anything comes close to a supermassive black hole? So astronomers have been really excited about seeing this and seeing what's going to happen. Initially, it was thought that this was just a gas cloud, but as people began observing it, they just kind of noticed, it wasn't stretching apart as much as if it was just gas. And so some astronomers, and Fraser actually got to talk to Andrea Getz from UCLA last fall, and she kind of explained how there are kind of two camps on this. The astronomers who think it is a simple gas cloud, and other astronomers who think there might be something inside it. Well, it's not too dramatic. It's probably just a small star inside of it. Maybe, maybe I'm thinking a brown dwarf type star. It's not. I don't think it's especially bright, and it's not especially big. Some estimates are 3 times the mass of Earth, so it's not especially big. But anyway, so it's been kind of in the news. We did a big article this week, and now just today, and I've just posted an article about it on Universe Today, the latest observations from the UCLA Galactic Group's Center Group reported that G2 is actually still intact, and it has probably already passed its closest approach to the supermassive black hole. And so they conclude that that does mean that it probably is more than just a gas cloud, that there is a star inside of this cloud of gas. It is stretching, and it is brighter. They haven't seen like a flash or any indication that it's been consumed by the black hole or completely torn apart. So anyway,
is it doomed? It's doomed, isn't it?
I would say it's pretty much doomed. I mean, it is being stretched apart. But as of, and now these observations were done with the Keck Observatory March 19th and 20th. And so, we are over a month past that. But,
so do you know, like, sort of like how far away it is from the supermassive black hole?
Yeah, it's actually, in human terms, it's really far. It's about as far from the edge of our solar system it's about 100 times farther than the distance from the sun to the Earth. So probably
100
about as,
AU, right?
yeah.
So like,
That's still pretty close.
yeah, that is
That's
close.
disgusting.
Beyond the
yeah.
orbit of Pluto, but
Yeah.
still relatively close. Yeah.
In galactic terms, it's pretty close.
Yeah,
so,
it's a 4.1 million solar mass supermassive black hole that it's about to sweep right past and just get distorted all to hell. So
right now, last year, the observations that were reported last year was that it was pretty stretched, and I can't remember the what was reported, but so it is being distorted, is probably going to fall apart, but and it might not be completely consumed. It just kind of depends on how all the dynamics work out. So it's just really interesting to watch.
awesome.
We so infrequently get to watch things happen out in space on human timescales.
Right.
To see this gas cloud, floating by a giant black hole is a pretty unique opportunity.
Right. And the astronomers have said that they don't usually get to see things like this taking place over the time scales of months, because usually in astrophysical terms things take a long time to happen. But then, of course, it is important to note that G2 actually probably met its demise about 25,000 years ago, because of the amount of time it takes for light to travel that far to our little eyes.
Awesome. All right. Well, let's keep rolling. Michael Jobin says that Universe Today is a Babylon 5 news publication. Is that right? No, that is absolutely wrong. I deny all knowledge of this Babylon 5 that you're
If you go
discussing.
to Zahadun,
I've never even heard of it, and definitely wouldn't have used that as any kind of inspiration for this website that we've been running for 15 years. So let's. That is a categorical denial from me. All right, let's move on. So Nancy, do you want to stick around? Do you want to cover one more?
Sure. What do you
Okay.
want me to talk about?
Do you want to talk about the live stream from the ISS?
Sure.
And if
This is pretty cool, and let me just get it up here so I can
well,
see.
you talk, and I will try and get it going.
Okay. Well, starting just this week, and actually I think it went live day before yesterday, a new experiment was brought to the space station on the Dragon spacecraft, making the payload run to the International Space Station, and it was attached on the outside of the Columbus module on the space station, and it's called the High Definition Earth Viewing, and it's actually a student experiment, which is really cool. But what it is, there's 4 different cameras outside of the space station, and so we basically have HD video streaming back to Earth in real time. It's kind of mesmerizing to watch it.
Yeah, it really is.
Yeah.
Let's watch it right now. I think I could be safe from a copyright takedown, but now I'm completely paranoid. So
yeah, there's a really cool view of just the Earth's oceans, I think, right now. It's very cool. It's just kind of neat to know that it's in real time, and it is really good, high quality video. It's HD.
And there's like 4 multiple cameras, right?
Yeah, 4 different cameras. So my understanding is that the 4 different cameras kind of
there. Do you see the shadow going across that instrument right there, right now? Boom. That's so cool. Sorry, please go on.
Okay.
This is live. This is live from the International
Space
Space Station. This is
right.
We're living the dream.
Yeah. So my understanding is that the 4 different cameras kind of cycle automatically, and they kind of switch between each other. So sometimes you will see the Soyuz, I think, that's hanging down from the space station, and then other times you get a clear view of, just like you're floating out there in space. It's really cool to watch. My productivity has fallen the past few days as far as work goes.
Yeah.
Thankfully, there's a 45-minute or about a 40 to 45-minute time period of where it's completely black because the space station is in orbital night. But so I'm able to get some work done at that point. But
and you can get that on Ustream. Just do a search for ISS live stream. Now there was recently the EarthCast folks had also installed a camera on the International Space Station, which has a steerable arm, and the goal was also to do this sort of live view from the space station. Have they gone live yet?
Well, the cameras are installed, and as far as I know, everything is working well. But it's not easily obtainable. I think when you go to the EarthCast website, they want you to sign in, and so it's a little more. And so I did go there yesterday, and I saw that they wanted me to sign in, and I just
forget
didn't
that.
Do that.
Sign in.
So not when I could just go over to Universe Today and see where we had posted the live stream and just watch it.
Exactly.
No problem.
Right. Everyone should go to Universe Today because that's the only place you can find this. All right. Awesome. Okay. So let's get one last thing here, and then I'll let you go, and that is this great selfie from Curiosity. I don't know if you saw it.
It's a really cool. Selfie, and I don't know which one do you have up? Okay, that
I've got
one.
the one. This is Jason's. So Jason Major couldn't join us, but he helped kind of make this selfie look really pretty. But
he did a really quick and dirty, but a very nice job of it, putting together probably about over 100 different images taken by the Curiosity rover, and I think it's fairly recent. I think the images were taken like on April 27th, if I'm looking at my calendar right. So yeah, it's pretty cool. I mean, you got Curiosity just kind of almost photobombing that image of.
It totally looks like it's photobombing.
Just leaning in there. So you got the mountain in the background and the cool landscape of Gell Crater there. So yeah, it's really neat. Now there's a lot of different versions out there. I think has NASA put out an official version of it yet? But I know that Doug Ellison from Unmanned Spaceflight put together a really, really nice, crisp one. And then yesterday on Universe Today, we posted one from Andrew Bodrov from Estonia, and he puts together interactive images like this, and so we've got the interactive one on Universe Today, so you can zoom around and kind of see what it's like to be standing next to Curiosity on Mars, which is really cool, and you can do a complete 360 and look around, and it's cool.
You know what's crazy? The live, just to go back for a second, that live ISS stream over on Ustream has now got 35. Let me see. Right now, there's 1,000 people watching, and they've had a total of 25 million views. Yeah. And that's literally just like how long have they been doing that for? Just a week?
Just this week.
This week.
I believe day before yesterday is when.
So if anyone
was
thinks
when it was installed.
That people don't love space, they love space. More cameras in space, please.
Yes.
Awesome. Okay. Well, Nancy, you are free to go.
All right.
I know you've got this story, and you just got to jump all over top of it. So I know you got a book. So by all means. But before you do, people should know where to find more Nancy Atkinson.
Okay, I'm on Twitter at Nancy_A, Google+, Facebook, and of course always on Universe Today.
Awesome. All right. Well, thanks, Nancy.
Right.
Get back to work.
All right. Thanks. All right. I will. Slave driver.
All right. Well, let's get on to the rest of the stories then. So where do you want to start, Morgan? Do you want to talk about the research spin-offs?
Yeah, why don't we start there? So every year, NASA publishes a list called spin-offs of technology that is out in the consumer world that was at least in part based on research carried out by NASA or NASA contractors. And this is kind of their way of saying, hey, look, all this money that we're spending on space, about $17 billion a year, it goes to benefit more than the scientists who get jobs and the astronauts who are up in the space station. This all eventually rolls downhill and impacts our day-to-day lives. And it's basically this 150-page book just listing instance after instance where NASA research has turned into products in the last year. And so I'll give a couple of examples. One is in car seats, as in the seat you sit in, not the car seat for a child. NASA, of course, has put a lot of effort into designing comfortable seats because astronauts can spend days strapped into seats when they're on their way to the space station or back when they were in the space shuttle. And so they did a lot of ergonomic studies to see where are the pressure points on your back and on your legs and things like that that lead to uncomfortable or stress-inducing seating positions. And then how do we fix that? And Nissan this past year took that research and turned it into new driver's seats for their cars. And I think it rolled out on maybe one model this past year, and they're planning to roll it out in all the other models in the coming year. But the promise is basically to give you a much more comfortable sitting experience for a long car drive. If you're driving cross country, you won't feel as stiff or as sore when,
that sounds
when
great.
coming out. Yeah, talk about it. Another example that's a little bit more, I don't want to say practical, but maybe important, is what they've done with the next generation of sort of environment generators. So this is a machine that was built for the upcoming Orion capsule that regulates the breathable air in the capsule. It makes sure that it scrubs out CO2, it scrubs out particulate matter, it heats the air to the right temperature, it humidifies it or dehumidifies it to the right humidity. It can even replenish the atmosphere after a fire in the capsule. And these are all important things for the astronauts who, again, are going to be cramped up in this small kind of room-sized capsule for days or weeks on end.
Yeah, breathing each other's sweat.
Exactly. Yeah. But it also has applications here on Earth. And one of the first places that it was integrated into, even before it's going to go out into space, is in survival habitats for miners. Because every year, far more people are trapped in collapsed mines than are ever going to space. And when a mine collapse occurs, you have basically just minutes to set up your survival equipment, get the air supply flowing before too much CO2 builds up. And when the collapse occurs, dust is just thrown up everywhere. This is very harmful to trapped people. And so by having this system where you basically just push a button and it starts circulating the air and cleaning the air and cooling the air and doing everything that needs to be done, this saves precious time for people who are trapped in collapsed mines underground.
What about elevators? That would work really well in elevators.
Probably a little too expensive to put in every elevator.
Yeah.
But you can take these expensive pieces of equipment and take key aspects of them and make them useful for everybody. And another example of this would be the water recycling system on the ISS. You might remember from a year or two ago that NASA has this $100 million water cleaning unit basically on the space station that takes waste products like urine and turns them into drinkable water. And of course that's very important on the space station because water takes up a lot more space than air does. You can't just ship an infinite supply of water and have people use it. And so they have to recycle, and they can recycle well over 90% of the water used on the space station.
Yeah, when you look at cities, so I mean, like cities like Las Vegas and stuff, which are completely dependent on dwindling water supplies, and so the kind of technology that will help you start to reuse and repurpose that water so that you can really make the fountains outside the Bellagio look nice is really key. So you can see that kind of spin-off technology having some use.
Right, and you can start that process by taking just a piece. And so one of the things that was done this year is a water bottle manufacturing company took one of the filters on the ISS system and integrated it into a water bottle. And so you might be familiar with filtered water bottles before. They usually have this little carbon soot filter in there, and the water runs through it. It scrubs out particles in the water, and you can drink. You fill your water bottle up in a creek, and you can drink it, and you're relatively safe. But by adding this extra filter in, they can also filter out bacteria. So things like E. coli or Giardia that aren't huge problems here in the United States, but just wreak havoc in countries that don't have reliable clean water supplies.
But you think that
just fill up a lake or a bottle out of a lake and drink it and know you're getting safe water for just dollars is literally a life-saving tool for people in many parts of the world.
Yeah, I mean, if you got like a water bottle company, though, supplying water, I don't know if it would be a real big marketing move to say that you're using 100% recycled water. I mean, obviously all water is recycled.
Yeah.
Yeah, but if you're like, in the store, made with 100% urine, that kind of thing. So,
Yeah, that's probably a little ways off still.
Yeah, all right. Cool. Well, let's move on. But I guess the big news was that NASA sort of gave everyone a big update on all of this technology and all that.
Right, yeah, they just want to remind you that it isn't just Tang or ballpoint pens that NASA has designed. Every day you touch something that was first designed for use in space, and the government spent the money to do it then, and we reap the benefits now, and they just want us to remember that.
Now, what about trampolines?
Ah, yes.
So the trampolines that my children use, was that designed to help people get to space?
Now, you'd have to jump pretty high up to hit a trampoline and then head out of the atmosphere. But this comment resulted from the recent tensions between the United States, really the world, and the Russian Federation over the uprisings, the instability in Ukraine. And as a response, the United States, the European Union have been slowly ramping up sanctions against certain industries in Russia and certain top officials in Russia. And one of those industries that's been affected is space. And NASA now is barred from working with Russia on space endeavors that don't directly involve the International Space Station. And the U.S. government recently barred companies from exporting basically technical goods to Russian companies. And this is ratcheting up tensions in what's an important sector of the Russian economy. And so, kind of out of frustration, the deputy prime minister of Russia last week tweeted basically that maybe NASA needs to consider sending its astronauts up to the space station on trampolines. This is kind of a veiled threat saying, pointing out the reality of the situation, which is, the rest of the world is dependent on Russia for access to and from space. Now, it's unlikely that the Russian government would ever act on these threats because they're incredibly lucrative for the government. One astronaut ride to the space station costs the U.S. about $70 million, and we're about to make a payment of about $500 million to the Russian space industry for services rendered. And, that's a lot of money. That'd be a lot of money for NASA. It's even more money for the Russian Space Center. And it's unlikely that they would withdraw that sort of.
Yeah, and so I wonder if there's a company in the United States that could be prepared to take on some of those contracts.
I wonder. I wonder indeed. It's certainly, it's the risk that Russia runs with this is to push NASA and the U.S. government into the arms of SpaceX and Boeing and Orbital and companies like that. And right now, we're years away from launching astronauts to the space station on private companies' spaceships. But with money, that schedule could be accelerated, and that would just make Russia more irrelevant in the space industry even quicker.
All this tension had to have been occurring to Elon Musk. He's been watching it, and I mean, the Dragon capsule is cheese rated, right? It can launch a human astronaut's worth of cheese to the International Space Station. And so, we've talked about this before, that, what was the last estimate? A couple of years, maybe?
2016 that they're quoting right now.
Yeah. I'll bet they've got plans to try and accelerate that. I wouldn't be surprised if SpaceX comes out early and is able to start supplying astronauts to the space station. And then that's it. I mean, then all of this saber-rattling and blustering is lost Russia hundreds of millions of dollars, and it's too bad. I mean, I'm really torn. On the one hand, I love international cooperation because more international cooperation and international trade that you have, the more peace you have. You know, you're not going to invade the country that's buying all of your goods and services. So I really like the idea. And if I had my preference, I would way prefer to have all of this sort of space stuff done in a disaggregated way across the entire world. Everyone's got a piece of it. Everyone's working on it. We're all collaborating. We're buying and selling from each other. And then there's no reason to pull out your guns and invade Ukraine and any of that stuff. And at the same time, there's got to be redundancy. There's got to be a way that you can say, oh, the Russians can't do it. No problem. SpaceX is ready to go. Oh, no problem. ESA's ready to go. Oh, no problem. The Chinese can handle it. But right now, there's just the Russians. So they've got all the power in the world to put the screws to the United States and the Europeans and just say, nope, nobody's going to the space station until you guys laugh at our trampoline jokes. And that's really obnoxious. And so, if anything, just to get that redundancy, to get those options, you want a free market. You want a way that people can say, oh, the Russians are too expensive, let's switch to SpaceX. Oh, SpaceX is too focused on Mars, let's go and deal with the Chinese. And I wish that was the way things will go. And 2 years from now, that is going to be the case. You'll have some competition, and things are going to be better. So,
yeah. Well, when you have an investment the size of the ISS, you want a front door and a back door. The ISS costs more than $150 billion to build, of which the U.S. taxpayer has picked up more than $100 billion. And you don't want to float $100 billion and then have no way to go after it. And I think that that's becoming increasingly obvious to people in NASA and to politicians, and that's only going to push us towards diversifying, whether that's towards international cooperation or public-private partnership.
Yeah, absolutely. Cool. Well, we got a few more sort of little bits of SpaceX news. Now, last week you talked about the Falcon rocket returning from space, the first stage, landing gently in the ocean. And I know some people kind of took you to task in saying that, in fact, like maybe it wasn't hovering, that it was landing in the water. But new videos, new horrible, scratchy, unplayable videos have come out, and what have we seen?
Right. So last week I said that the Falcon 9, after returning from launching the Dragon capsule of the ISS, hovered over the water for 8 seconds. And someone got on YouTube and pointed out to me last week that, in fact, it didn't hover for 8 seconds, it floated for 8 seconds, because the rocket can't basically turn its throttle down enough to reach hover yet at this point. But the big takeaway is that it landed softly as opposed to just plunking in at hundreds of miles an hour. And they had video of this, supposedly. But the storms were bad, the weather was bad, they weren't really able to transmit that video clearly to waiting ships. And so what they put out is about 30 seconds of the worst video you've ever seen. I mean, think of the worst VHS tape you've ever seen, and then just take a screwdriver to it, and then put it in the machine again.
Yeah, totally.
And it kind of looks like what they've put out. And they're hoping that amateur internet denzians will be able to clean this up and make it look like something. I'm skeptical. At most, I think you can see the rocket for about 3 frames near the end, and the rest is just basically a gray screen.
Yeah, there's like one frame that looks good, and you could see the legs out, the ocean below, the side of the rocket, and then it's all just garbage again.
Yeah.
So that video is not conclusive evidence of anything.
Unfortunately, we're going to have to wait for another.
But it's not long. It's just a couple of weeks, right? And then we're going to get another test.
I don't know when the next launch to the space station is, because I don't know when the next launch to orbit is.
Yeah.
But they intend to basically test on every launch now, and they do both public and private launches. So they could be launching, a communication satellite or a TV satellite or something relatively soon, and be able to test on something like that.
And this is it's the Orbcomm Falcon 9 in 2014. What's the date? Sorry, I don't have the date. Anyway, Yeah, and I mean, Elon Musk said that this is the most important advancement that SpaceX has ever made, and I think if this works, it is one of the most important advancements in the history of rocketry for the last couple of decades. I mean, this is a gigantic, leap forward. If they can get to the point where these rockets are taking off, releasing their upper stages, decelerating, returning to the launch pad, refueling, popping another upper stage on top, and they're heading up again, or that's a total game changer. It's going to decrease the launch costs. It's going to just increase the speed, the turnaround time, and what that's going to give us, and I think it's really important, is that it's going to allow people to launch things into space that they never thought they wanted to do before. And this is the exact same reason. We have high-speed bandwidth into our houses. We have high-speed bandwidth to our mobile phones. What do we use it for? Stupid, ridiculous things. Like broadcasting a space news show from your house, watching YouTube videos and watching sleepy cats fall over. I mean, the point is that we don't know what we're going to use this stuff for. We just know that if the prices come down, we're going to use them. And so new ideas, new technologies, new missions are going to be thought up that never would have been possible when it was $10,000 a kilogram, $1,000 a kilogram. But when it gets down to a few $100s a kilogram, some missions are going to start to make sense.
This was the dream of the space shuttle back in the late 70s, early 80s. The space shuttle was supposed to launch, 20 to 50 times a year. In fact, after Challenger, it never launched more than 3 or 4 times a year. But it was supposed to make access to space inexpensive, timely, and routine. And now it seems like we may finally be on the cusp of sort of achieving that dream. And once we do, you're right, the limits to what, how we can make use of that are basically as far as we can imagine.
Yeah, and so, this is not about just decreasing the launch cost of the existing ideas that we've already seen. This is a whole other world. I don't know when the next mission's going to launch. I apologize. It's soon, anyway. They're going to have another SpaceX launch soon. So this is really SpaceX's. I mean, if Boeing and Lockheed Martin haven't got something similar in the works, I think they're just going to get killed. And speaking of Boeing and Lockheed Martin, and we talked about this a little bit, that SpaceX is trying to do an injunction, or it's trying to stop the U.S. military from just buying a bunch of rockets from these guys, and now the court has awarded them an injunction. So they might get a chance to bid on these launches.
So SpaceX is not only using the Russian troubles today to sort of boost them forward into manned spaceflight tomorrow, they're using it to benefit themselves today, because the reason the injunction was awarded in the first place is that the Atlas V rocket, which is built by Boeing and Lockheed, is based on parts from Russia. And with these newest round of sanctions, SpaceX filed a lawsuit saying that this deputy prime minister of Russia, one of the people who's targeted in the sanctions, actually benefits financially when these rocket engines are purchased from Russia. And because of that, we can't buy things, from companies that he owns, more or less. And that stops Boeing and Lockheed from buying these critical components from Russia to build the Atlas V, and it basically puts a hold on this contract until it can be sorted out.
Yeah. And then more news. Yeah, man, you remember in the olden days we used to talk about NASA all the time, but now we're just going to talk about SpaceX. Is they did another test of the F9, and this is sort of that technology that lands, and they got up to 1,000 meters.
Right, so this is the opposite end of what they tested last week, where they tested coming down from the upper atmosphere and landing somewhat slowly in the ocean. Here they're starting from the ground. They blasted up 1 kilometer, that's about 3,000 feet, and hovered and then precisely landed back on the landing pad. And this is sort of the final piece of the puzzle, is once you're up there, coming down to a pin-perfect location so that you can land safely and repeatedly. And they've been working with the Grasshopper for the last year or two on this, and this has been their most successful test yet.
Yeah. So two people have jumped in with the comments, Helg Bjorkhaug and Albert Vandersluis. The next F9 is on May 10th. So,
okay. So
yeah,
just a
so
week.
just a week away from now. So I was right. Soon. Cool, but yeah, look at this. Yawn rocket takes off, gets to a
Yeah, I mean, it's
kilometer,
already
lands again on the launch pad with pinpoint precision. Oh, tell us something.
2 years ago, we
Yeah.
were here ranting and raving about how amazing this is, and
Yeah.
now it merits about 30 seconds.
Yeah. Whatever. Let's move on. Let me know when it's an upper stage. Okay. So I'm going to show a picture. Let's show this picture of another pale blue dot. Let's see if this will work. All right.
There we go.
Is that coming through?
Yeah.
So I don't know if people can see. So we got, I don't know, some planet's rings there in the bottom right and some kind of pale blue dot. What are we looking at?
Yeah, so we're looking at the rings of Saturn. That dark area in the bottom right corner, that is the outer edge of the A ring. And in fact, you can see the Keeler gap right there at the edge. Then we have this big black region, and outside of that, cutting through the middle, is the F ring of Saturn. And then out past that, you can see a little dot, which is the planet Uranus.
Awesome. And this was captured. This is captured by Cassini, so it's not just taking pictures of Earth; it's also taking pictures of Uranus.
That's right. As Cassini orbits around Saturn, it basically gets every angle on the solar system, and you could probably line up every planet within the rings at some point if you were just judicious enough about where you looked.
Yeah, fantastic. All right, I think we've covered all of the big stories that I want to talk about. So you put in this beta pic rotation rate. So why don't you sort of tell us what that one's about?
Yeah, so this is cool because this is the first time we've determined the length of a day on an exoplanet. And so a day, of course, is how long it takes for the planet to make one full rotation. And here on the Earth, that's 24 hours. But at Beta Pictoris b, that's only 8 hours. And that's incredibly fast. The fastest planet to rotate in our solar system is Jupiter, and it rotates at just about 10 hours. And this planet, Beta Pictoris b, is big. It's Jupiter-sized. And so the outer edges of the planet are rotating at about 100,000 kilometers per hour. That's as opposed to about 1,700 kilometers per hour here on the Earth. So 50 times faster if you were to be at the edge of Beta Pic than if you were to be standing on the Earth. And so Beta Pic was first discovered 5 or 6 years ago, and it was one of the first exoplanets to be directly imaged, which means it's close enough within 100 light years that we could take a picture of it and see it sitting right next to its star. And because of that, because it's close and easy to see, we can use techniques that we couldn't otherwise use on exoplanets. And so what they did with this, to determine the rotation rate or the length of the day, is they looked at it with a radio telescope. In this case, the Very Large Array, which is out in New Mexico. And what they did is they looked at one edge of the planet and they measured the wavelengths of light coming to it. And then they look at the other edge and they measure the wavelengths of light. And because the planet's rotating, one edge is moving away from us when that light's emitted, one edge is moving towards us. This is the Doppler effect. And by seeing the difference between those two, they can get a sense of how fast the edge is moving. And once you know how fast the edge is moving, 100,000 kilometers per hour, and you know about how big the planet is, you can turn that into a period, which is about 8 hours. You're muted for me.
I'm muted. That's insane. That's insane that they were able to measure the Doppler shift of the speeds of rotation from the two sides of the planet.
Yeah, this is a technique that until now we've only been able to do for stars, and stars are hundreds of times larger than planets. And so this is, exciting. And there are other, directly imageable exoplanets nearby to us, and so we can start to build up this catalog of not only how big a planet is, not only how much it weighs, but how quickly it's rotating. And this is important because that gives you information about how the planet might have formed. And we really don't understand yet how the formation process of planets is tied into how fast they rotate. because all the planets in our solar system rotate at different rates. They rotate, from 10 hours to Jupiter to over 200 days for Venus. And by getting more and more information, we'll be able to hopefully uncover some sort of trend that lets us understand what sets the rotation rate of planets like this.
God, it's crazy. That is just crazy. All right, cool. Well, let's move on. So I think the last thing we'll do today is we'll get your review of the latest episode of Cosmos. I guess episode 8.
8, yeah, 8 out of 13. We're coming down the home stretch now.
And I haven't watched this one. I watched 7, and I put on 8, and then the kids got busy, and we all were running around doing stuff, and so I didn't get a chance to watch it.
Yeah. So episode 8 is all about stars. It's about how stars work, and mainly it's about how stars die. So talking about things like nova and supernovae and hypernovae and the remnants that are left behind after a star explodes, whether that's a white dwarf or a neutron star or a pulsar or a black hole. And this is, I think, a lot more the kind of episode that I expected the show to be. It was really flashy, lots of CGI. It was gorgeous. It was really pretty. And it was about stuff out there in space today and what we know about it today, and less about sort of the history of science in general. And so I guess personally, I'm a big fan of the history, and so I really enjoyed some of the past episodes that were very history focused. But in terms of talking about an event, a piece of knowledge that we know today, that it did a good job, and it really sort of brought that viscerally to viewers. And my favorite thing probably was that it took these two-dimensional images that we see from the Hubble Space Telescope all the time, and it turned them into these beautiful 3D renderings. And these pictures, and these are famous pictures that you've seen if you've ever followed the images from Hubble, and it brought them to life. And they were moving and swirling and twisting, and it was a whole new look at some of these fantastic Hubble images.
So it's funny. So this felt like, I haven't seen it, so I'm going to have to just sort of have you explain it to me. But I mean, a lot of the complaints for people has been that there's been a real heavy reliance on these cartoons, on these historical cartoons, as opposed to this swirling space porn that you're describing.
Right.
And so, you got what people wanted. Do you feel like this was a more satisfying episode? I mean, do you think if Cosmos had sort of stick to this kind of stuff, that it would be doing better in the ratings, or what do you think?
Well, I'd say that personally this episode was less satisfying to me because, like I said before, I kind of like the history of science aspects.
And me too. I feel like it's a braver direction to go to tell these stories, a lot of which are even new to me,
Now, that being said, Cosmos is by no means doing poorly in the ratings. I think that it's at least meeting Fox's expectations. It's holding its own against scripted shows on Sunday nights. And so, I think that if anything, this is just going to appease an even broader audience. Because you have people who are interested in the history and like the cartoons and like finding out how we know the things that we know, but you also have people who basically just want to see all the coolest stuff that their tax dollars are paying scientists to discover today. And going forward, maybe we'll be seeing, now that we move into the modern era more and we have more pictures and things to talk about, maybe we'll be seeing more of an interplay between those two sides of the story.
Well, let's hope they get a second season. let's just hope. I mean, that's really the goal, right? Is for people to look at this and they'll get a second season.
Yeah, I don't know if they're in talks for a second season or not. They're not pulling out. They're not holding anything back this season. That's for sure. They're not canceling.
They're definitely not canceling any episodes of it. So,
they're good.
And this one, I think, is like a lot of this kind of programs, they're going to live on in the aftermarket stuff.
Oh, absolutely. It's going to be a huge educational tool.
Yeah, totally. So, yeah. All right, cool. Well, let's wrap things up then. So, Morgan, and before I sort of let people know where to find out more about you, I just want to let everyone know that Morgan joined me for a very special episode of Astronomy Cast during the Hangout-a-thon. Morgan was gracious enough to answer a zillion of my questions about Saturn's rings, a topic that he knows a lot about. So, That's episode 344, which is probably going to get released fairly soon. It's just going to be plucked right out of the Hangout-a-thon. So, but if you didn't watch it, it was great, and I really enjoyed it. And Morgan, you have a lot of depth of knowledge about the Saturnian ring system. It was just great.
I think that's probably the latest at night that I've ever sat and talked about astronomy for an hour. So that was, a good thing to check off my bucket list. Post-midnight astronomy.
Awesome. Yeah, well, we only had to do a few hours. The good folks at
Cosmos
were up all night. And if you haven't already, and you do want to participate in the contribute to CosmoQuest, you can go to cosmoquest.org/hangoutathon, and they're still taking donations for the next 34 days as part of this fundraising effort. So if you haven't already, by all means go over there and kick a few bucks towards CosmoQuest and help us continue doing all of the outreach and research that we're doing. Okay, cool. So Morgan, where can people find out more about you?
Yeah, well, first off, I'll be taking questions this afternoon over at the Google Plus Space Community. So if you have a burning question or comment or just want to know what's going on, hop over there, go to googleplus.com or plus.google.com, and click on Communities, choose Space, and you'll see the Q&A area right there at the top.
Awesome.
You can find out more about my writing at cosmicchatter.org. You can follow us there on Twitter at @cosmic_chatter. And now you can follow me and my ramblings, personal ramblings at Morgan Renberg, and drop me a line there as well.
Couldn't get at Morgan?
I tried at Morgan. I tried at M. Renberg, but somebody in Scandinavia stole that from me and hasn't posted in years. So I had to go with the thing.
Well, of course, I am the publisher of Universe Today, and we just released a new video called "Does Light Experience Time?" And it's a very weird video, and it's also very experimental with me walking. So if you haven't already, go check it out. It's just live on our YouTube channel. If not, go to universetoday.com, and you can see all the news. You can follow me as I'm F. Kane on Twitter, and of course, very busy on Google+. So thanks, everyone, for watching, for joining us this week, and thanks again, Morgan, for being what is turning into my co-host for the Weekly Space Hangout. I really appreciate sort of you being able to show up, week after week, and even if it's just the two of us, I think people really still enjoy the show. So it really means a lot to me, and I know it means a lot to the fans who watch it. So thanks, everyone, and we'll see you all next week.